Hello everyone, welcome back to my Godot study session. Again, this can be used as a study aid or a sleeping aid, whichever. It's probably going to be another long one. I really want to get through learning these step by step. Might take some breaks in between because there are, I believe, 27 lessons, so that's going to be a lot, but I think they're pretty simple, pretty small, so it shouldn't be like, oh, whoops. What did I just do? Uh-oh. Hello? Already off to a great start. Okay, there we go. So I'm on lesson 3. So feel free to follow along or not and just have this on the side while you're doing your own thing. That's completely fine too. For today's music background, I found this really cool playlist called Zen TV by ARPwire TV. It's like Frutiger Arrow Vaporwave mix. So hopefully it's not too distracting. I'll put it kind of at minimum volume so it's not as loud. Isn't that cool? Just, early 2000 vibe. Miss those times. Alright, so we stand on the shoulders of giants. As programmers, we rely on a lot of code created by others before us. Yes, every programming language comes with a wealth of features created by other programmers to save you time. We call a bundle of code created by fellow developers a library. It's a bunch of code sitting there, waiting for you to use it. Game engines like Godot bundle many libraries together. Game engines like Godot bundle many libraries together. They provide a massive tool set to save you time when making games. You'll always use a lot of existing code. When coding, you always use a lot of code from developers who came before you. In a moment, you'll write your first code. You'll use functions created by the Godot developers. A function is a list of instructions with an exact name. We can tell the computer to execute all the instructions in sequence with that name. Calling functions. When you tell the computer to execute a function, we say you call the function. To call a function, you write its exact name followed by an open and close parenthesis. To call the function named show, you would write show parenthesis. In Godot, calling show makes something visible, like a character or item. The complementary hide function hides the entity. Oh, interesting. So there's a library that made these functions already. So, you can still create funcs like this, like your own run, but they have functions that are like show, hide. Oh, that's really nice. Okay. Once an entity is visible, calling show again doesn't have any effect. Right. Similarly, once you hide something, calling hide again doesn't change effect. Click the run button on any example below to execute the code listing. So hide. Can I rewrite it? Okay, no. Run. Okay, well, then show would be a different one. In the code listing above, we write the function call hide in a new function named run to execute the code. Creating a new function is necessary to execute instructions in GDScript. Right. So even though they have a func called hide, you need to create a function that will call this instruction of hide. Okay. Can you tell me more about that run function? Inside. Yeah, we must write, unlike in some other languages, we must write our code inside of custom functions. Okay, so GDScript has libraries of functions to use, but they cannot be called singularly. You have to call them in custom functions, which are like their own blocks. So they're like little Lego. So if you think about it this way, your custom function is like the Lego building that you're making. Let's say I'm making like I'm looking at my Animal Crossing Lego set, like a table with flowers. So my function is called flower table, and the flower table has water, like water plant, or just water function, which is a built-in it's from the library that GDScript has. So I can't just call water. Like where's the water gonna go? Like who's watering what? So I have to have a function, a block called flower table to water the flower on the table. I don't know if that just made sense, but to me it makes sense, so whatever. Let's see. You'll learn what functions are and how they work in great detail in the course, but here's a quick look at them if you're curious. It's a bundle of code you can execute anytime. Yes. You need to write the func keyword, the function's name. Yep. The body is a block of instructions. You have to do the tab. Yes, yes. Okay, cool. Thank you. Function arguments. We use parentheses to call functions because you can give the function arguments inside the parentheses when calling it. Here's a sprite standing straight. If we call the rotate 0.3 function, the character sprite turns by 0.3 radians. Right. Nice. Okay. The 0.3 part between the parentheses is the function's argument. That's an integer. Arguments are values, numbers, bits of text, and more that change how the function behaves. Arguments let you fine-tune the effect of the function call. They can be optional at times, but functions often require arguments in order to work. For example, calling rotate without any argument would result in an error. Right. Without an argument, Godot doesn't know how much you intend to rotate the sprite. Don't worry about memorizing what arguments each function requires or accepts. As a programmer, the documentation will always be close by for you to refer to. Finally, notice how we use a dot in the number 0.3. It's a decimal, a float. There's floats and another version of a float, I can't remember. You need to use a dot like this to represent decimal numbers. You can't use commas as they have a different purpose in code. Yes, that means there's more than one argument if you use a comma instead of parentheses. What are radians? The value of 0.3 is an angle in radians. In daily life, we're used to measuring angles in degrees. Oh, you're so right. The radian is another scale commonly used in video games and math. You can convert radians into degrees by multiplying them by 1. Oh no, not math. Oh god. Pi, like 3.14. Oh, it's nice you don't have to like type it in, it's just pi. Which means if you want to yikes, okay. An angle of pi radians. Okay, radians are a way to measure angles based on the radius of a circle. Okay, that's fair. To get the angle in radians, you can take the circle's radius and wrap it around the circle. That angle is 1 radian because you're wrapping the radius 1 time around the circle. Those two. Oh my gosh. Okay, guys, I'm not a math whiz. This will probably I'll have to come back to this later. I have to know math if I want to program. But I don't like math. I'm sure this is super simple. It's just a little too early for me. I have a cherry dog right next to me. To wake me up. It probably is really simple. I just have to plug in the numbers. And it's whatever. For rotations, but also I wonder if it's for maybe when like camera angles, like if you're turning the character's head side by side, you have to do it by radians because, you know, if you're following their paw, it's like a kind of third paw, but you're like behind the character, you're gonna have to know how to handle rotate in like radians. What does the code below do? Select all that apply. Show calls the function named show. It makes the entity like a game character sprite visible. It does not call the function. A custom function would call the function named show. This by itself makes the entity appear. Wait, what? I was wrong? So it's both. Okay. The code calls the show function, and doing so makes the game entity visible. Well, I thought you just said that you need a custom function to call the built-in function. Or am I wrong? I thought that's what you guys just said. You can't call it without didn't they just say it somewhere? Yeah, in GDScript, unlike in some other languages, we must write our code inside of custom functions. Oh, maybe this when they're saying custom functions, maybe they just mean like you have to write them and you can't like write the instructions by itself without it being in a function. Okay, alright. That's probably what they meant. Okay. Wait, what? Oh, I didn't read this, I'm sorry. Another example with the move local x function, you can move the character to its left and right. move local x. Oh, okay, yeah. The function takes one argument, a number of pixels to offset the entity. The complementary function move local y makes the character move up and down. This is one way to move a character in a game, although we'll see more powerful ways to do this later. Powerful. Okay. Oh yeah, you're gonna definitely have to have something that alternates it on. Like, you're gonna have to have a function that can call whenever someone moves like up and down, it can change the variables inside consistently, or else this would be really annoying to have to deal with. Y move local y 20 moves the character down. Oh, because instead of it negative, with positive values, the code above moves the robot to the right and down. With negative values, it will move up. This is probably different than what you studied at school. In math classes, the horizontal axis moves to the right, like here, but the vertical axis points up. In video games and generally in 2D computer graphics, the vertical axis points down instead. So whenever you move something on the y-axis with a positive value, it'll move down. Interesting. I like to think of it like weight, like, you know, weight, like gravity. The increase of gravity means the more you're going to go down. So the decrease of gravity, it's going to be negative, right? Well, if you're at 0 gravity, you'll start floating, but you get my drift. It's like weighting the character down and then taking the weight off. How do you call a function? What is the syntax you use to call a function in general? You write a value, like a number, followed by an opening and closing parentheses. You write its name followed by a colon. You write its name followed by an opening, followed by an opening and closing parentheses. How do you call it? You write its name followed by an opening parentheses and a colon. Oh, you can only choose one? It's that one. To call a function, you need to write its exact name followed by an opening and closing parentheses. Yes. Make the character visible. The robot's invisible. Call a function to bring it back. Yes, which is the show function. Continue. And then the robot is turned by negative 0.5 radians. You need to make it upright by calling the rotate function. Please call rotate inside the run function. So if we rotate it by how much, we want to put it back to normal, so we have to do it by 0.5. Yeah. I want to stay if you did it by 10. I know. So if you do 0.5, and then we want to do move local x, we want to do like 15, move local y by negative 30. Oh, it's not doing it. Why? Is it restricting movement? Okay, well. Alright, well, it's whatever. We'll use code created by others. Oh, drawing a rectangle. We'll use code created by others like we did in the previous lesson. This time we'll solve a more complicated problem, drawing shapes. Dun dun dun! I'm gonna take a cherry dog. Man, hold on. Okay. I'm still trying to wake up. Man, I slept a lot too. Maybe it's like because I overslept or something. Like, I did more hours than I usually did, and now I'm just like, ugh, gotta wake up. Okay. So, co-create by others like we did. Okay, this time we'll solve a more complicated problem. Drawing shapes. Meet the turtle. We present you the turtle. Hi, turtle. We created the turtle to teach you how to call functions. Thanks. The turtle is a little machine that moves forward, turns, and draws lines along its path. To make it draw, you give it a list of instructions. On each code line, you call one specific function. We prepared several functions for you. Move forward, pixels, makes the turtle move forward over a given distance in pixels. Turn right, oh, now we're not doing radians. Okay, so turn right degrees makes the turtle turn clockwise by a precise amount of degrees. Turn left degrees works the same as turn right, except it turns counterclockwise. You'll use these functions the same way you used rotate before. The turtle draws a white line as it moves. We'll use this line to draw shapes. For example, to move the turtle 200 pixels, you would write move forward 200. It looks like he's like a spider turtle. Turning left and right. The functions turn left and turn right work the same. To turn 45 degrees to the right, you would turn right 45. If we call turn right 45, the turtle turns 45 degrees to the right before moving on to the next instruction. So move forward, turn right, move forward, turn left, move forward. Yeah. Nice. While using these instructions, we can make any two-dimensional shape we like. Try to understand the example below. In the next practice, you'll use the functions we saw above to first draw a corner, then a rectangle like this one. Okay, move forward 200, turn right, turn right. Oh, so we're making a square. Very nice. In the function call below, which part is the argument? The argument is the 30. Yeah. A function's argument are all the values inside the parentheses. In this case, there's only one, but there can be multiple separated by commas. Yes. The turtle uses code made specifically for this app. The turtle is a little learning tool custom made for this course based on a proven code learning methodology. It's designed to teach you how to use and create functions. So please don't be surprised if writing code like turn left inside of the Godot editor doesn't work. Oh, and don't worry, once you've learned the foundations, you'll see they make it faster and easier to learn Godot functions. Let's move on to practice. You'll get to play with the turtle functions to draw shapes. Period. Use the turtle to draw a square's corner. You'll then build upon it to draw a rectangle. Okay. The corner is made up of two lines that are 200 pixels long. Okay. So we're making a corner, right? So you're turn forward, turn right, and then go forward, is what you're basically saying. They're very much giving you the answer right there. But that's a square's corner. Yes. Okay. Add the correct arguments to the functions. Move forward and turn right to draw a rectangle with a width of 200 pixels and a height of 120. So width of 200. So turn right 90. And then go 120. Turn right 90. Then go 200. Turn right 90. Then go 120. Yeah. Period. Write out calls to the functions move forward and turn right to draw a rectangle with the width of 220 pixels and a height of 260 pixels. Okay. Alright, well, we can just take from these. Stop! Oh my gosh, you're so annoying. Okay, but instead we're gonna do, you said 220? Oh wait, 260. Turn right 220, and then move forward one more time. And that's 260. I might stay just to like, what if I could make a triform? Oh my gosh, should I challenge myself to make a I don't know degrees like that to BH, but I'm gonna try it anyway. So if I want you to go Well, they don't know how to do diagonal. Oh, they don't know how to do diagonal. I was like, let's make a triangle. I can't make a diagonal run. Oh, actually, maybe. Because if you move forward by 100, you turn right by... I'm so dumb. Anyways, 45. Interesting. And I'm just probably too dumb for this. Well, there you go. Well, I just wanted to play around with that. There's no way I'm gonna make a Triforce. Forget it. I can't. I'm not good with degrees. I'm not good with this stuff. Yup. See, sometimes you just gotta be a goof. Alright, coding your first function. So far we have called existing functions that other developers wrote. In this lesson we'll talk more about what functions are and see some examples. Then you will learn how to define your own functions. Functions are named sequences of instructions. Yeah. Functions are sequences of instructions. We give a name. We call that name an identifier. Using the identifier, we can get the computer to execute all the instructions inside the function as many times as we need. This is what a function call does. Learn more about identifiers. Names. You cannot reuse the same name in a given space in your code. Right. You are so right. If there is any code that you need to run multiple times, you can put it inside a function and give it a name. The instructions inside a function can be any code you want, and they will all run every time you call the function. Here is the example of a move and rotate function that moves the turtle forward and then turns it 90. Move and rotate, move forward, move to right. Makes it easier. Move and rotate function consists of two instructions, each on a separate line, so you don't have to keep calling this all the time. We can just call this twice and then bada bing bada boom. You could write another function that calls move and rotate 4 times. 4 times. Yeah. 4 times, guys. To draw a square of length 200 pixels. Every time we call move and rotate, the two functions move forward 200 and turn right. Yes. In this simple example, it may not feel super useful. Here's a more useful and realistic. Oh yeah, draw square, and you have the whole list of the instruction. It's very nice. Oh, by size too. Oh, that's nice. And you can input the size. How to define your own functions. Let's break down how you define a function. A function definition starts with the func keyword followed by a space. Oh god. Hi. I'm trying. I'm doing my best. Definition starts with the func keyword followed by a space, the function's name, parentheses, and a colon. Func, name, colon. Yes. The instructions inside the function must all start with the leading tab character. You can insert that tab character by pressing the tab key. Yes, because it needs to be in the block. Yes, it's like their list. Why do we use functions? To put a name on multiple lines of code, to run multiple instructions in one go, to reuse code multiple times. All of it. Names in code have rules. Function identifiers cannot contain spaces. In general, names in programming languages cannot contain spaces. The computer uses spaces to detect the separation between different keywords and identifiers. Instead of spaces in GDScript, we use underscores. Okay, so they don't do the... It's like the snake case, the kebab case, and the... what's this case called? Let me try to like refresh my memory on the cases. Snake case, kebab case, and this is naming convention where words are separated by underscores and all letters are lowercase. Yeah. This is a name convention where words are separated by hyphens and all letters are lowercase. But then there's the other case where it's like Oh, camel case. Remove spaces and capitalize the first letter of each word in Pascal, but the first letter of each word is capitalized. I'm used to camel case, but snake case is basically Python, so nothing strange about it. Names and codes. Names in code have rules. Function identifiers. We just said this, didn't we? Oh my gosh. Okay. Instead of spaces in GDScript, we use underscores. We already saw this with functions. Yes, this is the convention we follow in GDScript. Oh, you know what I could have done? I could have went negative degrees. If I wanted to, like, quote unquote move backward, I could have just done negative. Oh my gosh, I'm done. Wait, that's so true. Wait, I'm so sorry. Can I go back? It's not 400, but it's like 420. Blaze it. Close enough. But we made a trapezoid, guys. Yes, names in code have rules. We did this right. This is the third time I almost reread the same paragraph. Yeah. Instead of using underscores, they start words with capital letters except for the first one. Camel case. With that convention, you'd write function names like move forward or move local legs. Identifiers also have to start with the letter or an underscore. You can't begin with a number, but you can use the numbers after the first character. So, which of the following names are valid function names? Move forward, make 3 new characters, and jump. Yeah. Instantly moving the turtle to a different position. See, look at these negative degrees. Oh my gosh. As you can see, my brain is like... it's so done. I've been going at this for like 40 minutes. I'm really trying to train this brain muscle of mine. I really want to get back into studying and making it a habit. So that's why I'm waking up early to do this. I'm like, okay, just get your brain moving. Okay, in order to draw multiple squares in different positions, we introduce a new function for our turtle to use. The jump function picks up the turtle and places it relative to where it is. So calling jump -150 moves the turtle by 100 pixels to the left and 50 pixels down without drawing any lines. Oh. Interesting. Yo, that's cool. Okay. A function to draw squares. Until now you've had to write code by hand and it's boring. It's time to code a reusable function. You'll use it to draw multiple squares. Drawing multiple squares, now you create a function to draw squares. You can reuse it by calling multiple times. Okay, make a function called draw square. Yeah. And then it's going to do move forward and turn right 4 times. Doesn't care. Draw a square of 200 pixels. Okay, move forward 200, turn right 90. And you're going to do that 4 times. I think. Yeah. And then now we're going to use the draw square. You have a function to draw 1 square, draw square. Use it to draw 3 squares. We already created draw square for you. Create a function named draw 3 squares. Yeah. Oh wait, hold on. You have to make sure it's separated. Func draw 3 squares, which takes in Does it have to take in anything? I don't think so. Because if it takes in like size and then we put size is there, and then I can call it later saying draw 3 squares. So like if you do like size, right? And then you say draw square. Oh, we don't need to because it already has a set size. Yeah, never mind. The set size is 200. So you draw a square, and then we want to jump. You said you want us to call 300. Okay. So you're gonna move to, what was it? Jump moves you 300 pixels to the right, and then, or it's X and Y. Yeah, okay, got it. Without touching the ground. And then you do draw square again. See, the thing is that you should always just probably get used to copying and then not having to read. Because sometimes the only problem is that when you rewrite, sometimes you might mistype, and that causes more error. It's better just to, you know, copy and then paste it. So, said 3 times, right? Very nice. Very cute. Yay! Okay. In the previous part, you created a function to draw a square of fixed size. This function is a bit limiting. Instead, it would be much better if we had a function to draw a square of any size. That's why I was saying, like, you know, you put an argument for size, but we had it fixed. Let's see. Any kind of rectangle, a square is a specific kind of rectangle. In previous lessons, you used the rotate function and gave it an argument. Yes, just like rotate, we can also give our function parameters. Parameters are labels you give to values passed to the function. Can I rotate in both directions? Yeah. For now, please focus on the first line, func rotate radians. When you call rotate 0.5, the computer binds the value 0.5 to the label radians. Wherever the computer sees the identifier radians inside the function, it replaces it with the 0.5 value. The parameter name is always a label you can use to refer to a value. The value in question can be a number, text, or anything else. For now, we'll stick to numbers as we have yet to see other value types. What is a function parameter? A label you give to a value the function receives. A number you use to make calculations. I don't think it's... Yeah, parameter is a label that represents a value. The value in question can change, depends on what you put in parentheses when calling a function. How to create functions with parameters. You can give your function parameters when writing its definition, the line starting with the func keyword. To do so, you add a name inside the parentheses. Func, draw square, length. And then you can give parameters any name. How you name functions and parameters is up to you. Just remember that names cannot contain spaces. To write parameter names with multiple words, you need to use snake case. The following function definition is exactly equivalent to the previous one. Func, draw square, side length. Parameters make your code easier to reuse. Here's an example with a function to draw any square. Use the slider to change the value passed to the function and draw the square of different sizes. They had this earlier, where it's like size, and then you can say, I want it to be 170. Or JK, I want it to be 200. Or JK, I want it to be 30. The smallest square. What is the correct syntax for a function definition? Func, function name, parameter name. No. It's the colon, func, function name, parameter name. Yeah. Functions can have multiple parameters. You can use multiple parameters in a function. In fact, you can use as many as you need. To separate the function parameters, you need to write a comma between them. Must write spaces between function parameters. It's better to. I don't think you have to, but it just looks all crammed. Oh, you must have a space. Okay, just kidding. Oh yeah, it doesn't matter if you, as long as you have the comma or either. Yeah, it just looks readable. Exactly, it just looks cleaner. The following example defines a function that uses 2 parameters to move an entity on both the x and y axis. Func move local xy, offset x, offset y, move local xy, offset. Yeah, so something that will always manipulate those. How should I name my function and parameters? It's up to you. You can also write abbreviated name like pause for position, BG for background, and so on. single letter. A math class is ABF. Complete and explicit. That's what I do. I'm like, I will detail it to as much as I can. It trains your fingers to type precisely. Or you can just literally copy and paste so you don't make the mistake of mistyping one of your names. That's just me. When defining a function, parameters are optional. You can define functions with or without parameters depending on your needs. What's the correct syntax to define a function with multiple parameters? With colons at the end. Find function name parameter. There's no commas, so yeah. Now it's your turn to create a function with multiple parameters, a function to draw rectangles of any size. Okay, drawing corners. At different sizes. Code a function you can use to draw corners with lines of varying size. Okay, using multiple parameters, drawing squares of any size, drawing rectangle of any size. Oh, with rectangles of any size, you have to have a fixed, a fixed X or Y line, most likely. Anyways, oh my gosh. Come on, Maddie. We're at this for 48 minutes. Wake up. Okay. Before we create a rectangle of any size, let's first see how we can use parameters to draw simple shapes. Here we can have an incomplete function that will draw corners with lines of any length, but it's missing its length parameter. Right. The function will move the turtle forward an amount defined by the parameter length, turn 90 degrees, and move forward. Complete the draw. Yes. So you're saying make a length parameter, have it by length, and then what you're gonna do is you're gonna call draw corner, and we're gonna say 100. Lesson is graphic design, so only you need to edit the important bits, but there's much more code outside of what you see that makes the project run. And then changes you mean. Well, I'm calling the function and saying I want the length to be 100. Are you saying that you have something already? The test case is already calling it? Okay, a test case is already calling it. Oh yeah, something's doing that because I didn't even say jump. Okay. So there's already basically the code behind what they're saying is that something is already in place to call draw corner, and it already has a length that they're using as well as like using a function of jump. So I don't have to call it. In this practice, we'll improve our draw corner function so the angle can also vary. Alright, so you add angle, right, and then usually you would call the function with the specified length and angle you want, but they already have that implied. We want a function to draw squares of any size. We could use these squares as outlines when selecting units in a tactical game, as a frame for items in an inventory, and more. Create a function named drawSquare. Okay. Yes. That takes one parameter, the length of the square sides. Okay. The turtle should face up towards the right when starting or completing a square. Be sure to call turn right enough times in your function to do so. Okay. Move forward length. And then turn right 90. Alright. Is that what we're doing? So they added a jump thing. Cool. Let's make our square, see they have a set, yeah. Let's make our square drawing function more flexible to include rectangles of varying sizes. Your job is to code a function called drawRectangle that takes two parameters, length and height. Okay, so the length is going to be this one, and height is going to be this one. Length and height. Okay. Lesson complete. Man. Wake up, dude. It's not even that early. Introduction to member variables. In this lesson, we take a first look at variables. In games, you need to keep track of many values that change over time. The player's score, every character or enemy's health, the last checkpoint, and so much more. You need to store, retrieve, and update those values. We call those values variables. Variables are labels you use to keep track of values that vary over time. Here's an example of a variable tracking a character or monster's health. var, health. Again, I hate that you guys use var. That's so... like, I would have to leave comments of like, this is an integer, this is a string. Oh my gosh. I hope that's not the case. We really have to call everything by var. I mean, okay, just we'll live. Okay. I understand var is just variable, but the thing is, it's global. But it's okay. Yes. So health equals 100. The line above defines a new variable named health and assigns it a starting value of 100. That's what the equal sign does. More on that below. Equal is like, that's right. Equal sign is assigning. Equal is comparing. Like, do these match? Like, if health is 100 and the achievement is have your health, like, do this without taking a hit. And if these two match, so you'd say if var health, or if health equal achievement health, then access the achievement. Yeah. Okay. Function parameters, which you saw in the previous lesson, are another example of variables. In this lesson, we start using variables built into Godot. They're a particular kind called member variables. Member variables are values attached to a game entity. They're useful properties like the position, rotation, and scale of a character. Like a vector's X. Props. I never really was good with props in JavaScript. I'm not even gonna lie. Like, I remember I was taught it and I'm like, yes, I'm gonna nod my head like I understand. But their member variables are attached to a specific value type. It's like ints. You must first write the value's name followed by the access operator dot. Oh, right. Yes, because you can create an object that has like color orange, color equal orange, and then whatever. It's like let's call it, the object is a cat, and you say cat dot color equals green, cat dot size equals 100. Like, you could do that. Yeah. So they're member variables to a certain object or a, whatever you call it, property. Right. In a previous lesson, we saw how we could use the rotate function to rotate our character. Yes, we did. This function increases or decreases the value of the entity's rotation member variable. Say we want to reset the rotation to 0 and make the character upright. Using the rotate function can prove difficult. You need to know the character's exact current angle to cancel it out. It's much easier to use the member variable rather than the function. The following code assigns the value 0 to the character's rotation, resetting its angle and making it upright. So rotation equals 0. robot.rotation equals 0, like kinda ish is what. Huh. Wonder if like the code in the background behind the scenes is what's helping with that. Notice how we use the equal sign to change the value of a variable. What's a variable? A function that varies over time, a label used to keep track of a value that can change. It's not a function. It's variables are labels you use to access values that change over time. You can also use them to put a name on a value you want to reuse throughout your code. It makes your code easier to read and to change. Oh, thank you. Sorry, got a little message. Accessing subvariables with the dot. In video games, you will see many member variables that have subvalues. For example, the position we mentioned has two coordinates, x and y. It's the same for the scale. It has x and y subvariables. They respectively control the horizontal and vertical size of the game entity. To access those x and y subcomponents, you add a dot after the variable name. The code below places the entity at 200 pixels on the x-axis and 250 pixels on the y-axis. Position.x, meaning this position's x, we're accessing its x to 200. And then this same position, it's y, accessing the y is 250. Notice how we use the equal sign equal to assign the numbers on the right to the subvariables on the left. Unlike in maths, in computer programming, maths, that's how you know this is not US. Because we just say in math, in mathematics or something. But I know I learned that in other countries they say maths. And I'm like, maths. In computer programming, the equal sign equal does not mean is equal to. Instead, it means assign the result of the expression on the right side to the variable on the left. We assign values so often in code that we prefer to reserve the equal sign for that. Fair. In games, the y-axis is positive going down. That's right, you guys said that. It's no longer going up. We're adding weight, so it pulls it down. Why does the y-axis... Oh yeah, we already talked about it. Let's look at one last example before moving on to the practice. The following code makes the character 1.5 times its starting size. Scale.x, scale.y. Okay. How do you access subvariables? Variables often hold subvalues, like the position has two subvariables and y. How would you access the x, for example? You write a dot, because that's exactly what you just said earlier. In a future lesson, we'll explain why and how those variables have subvariables. For now, you just know you can use the dot to access them. We'll tell you which variables have subcomponents and what their names are. In the next lessons, you'll create your own variables and do operations on them to add or remove, score, health, you name it. For now, let's practice accessing variables. Draw a rectangle at a precise position, using the member variable and its subvariables to change the rectangle's position. Okay, after this, I'm going to take a break because I'm hitting an hour. But let's do this. Draw a rectangle of 200 by 120 pixels at the x position of 120 pixels and y position of what? Hold on. Draw a rectangle of 200 pixels by 120. Okay, 200 by 120 at the x position of 120 pixels and y position of 100 pixels. Am I understanding this? You're saying at a rectangle, you want to draw a rectangle of 200 by 120 pixels at the x position of 120 and 100. Okay, sorry, I just had to break that down in my head. There's just too much pixel, 100 pixel. Okay, this is what they meant. Got it. Okay. Draw 3 squares of size 100 by 100 that are 100 pixels apart on the horizontal axis. Okay. So let's start at the starting position. So position dot x is 100 and position dot y equals 100, and you want me to use draw rectangle, which we have created before, Oh, interesting. Like, instead of draw a square, you're just saying draw a rectangle, but regardless, you're changing the length. The length and height. So this is what they're talking about. Oh. Well. Can I use the jump? Draw 3 squares. So. Okay, so, I can use the jump. 100. 100, we can do that. And we just do this. Wait, did I copy? I forgot the... Is that correct? Oh my gosh. No, that looks crazy. Well, that looks crazy. I mean, is this what they wanted? It just looks really weird. It just looks really weird. I don't like that it does that. Oh, did my Fruitiger play? Oh, okay, well... Did it end? Wow, it did end. Oh wow, yeah, an hour has passed. Okay. Look at us studying for an hour. And I only got to lesson 7. I did 4 lessons in an hour. Oh my gosh. I thought I could do a whole video just going through all the lessons, but I am taking my time learning, so... Obviously the most basic of basics, but... I guess this is okay if they wanted to... Because you have to start at this position. Unless I can call that outside... Which they probably won't let me do. Like, you establish this outside of it. And that way, you don't have to do that every single time. Yep, you can't do it. Damn. Okay. Because it looks weird. It just looks really weird. Okay, I just want to make sure that it stays. It's just like, what is happening? I don't know. Just continue. Alright, I'm gonna take a break here because I did hit an hour. I will see y'all later.